What's going on, guys? Figured I'd fire up the camera, take you guys along with me on a troubleshooting process that I'm going to go through on a piece of shop equipment of mine that has failed. And what we're looking at here is a ridgid shop vac blower head. It's a shop vac, but it also doubles as a blower. The head unit that I have sitting in front of the camera here comes off of the main canister, and it can be used either as the suction motor for the shop vac or as a blower unit. At one point I think it had kind of like a cone attachment that went on the one end, and you could use it to blow off your driveway or your shop floor, workbenches or what have you. And it's been a pretty good unit. I think I've had it for going on close to 15 years, if not even longer than that. I think I paid about $150 for it way back in the day, and it still goes for something around that price, 150 to 200. It's been a really good unit. I've actually already repaired it once in the past, a few years ago. I had set something on top of the motor blower vent there, which is where most of the heat is dissipated. And I forgot to take it off when I plugged the shop vac back in and started using it. It overheated the motor and burned up a thermal fuse, which I went through the process of finding and replacing for about $10. Certainly worth the price of repair. It was relatively simple, and I didn't have to buy another $200 shop vac. Now, that being said, it worked great for another few years until the other day I went to switch it on, and it was DOA, not working. And now, normally I'm running this, you can kind of see in my mess here, I'm normally running this through a cyclonic dust collector system that I put together. This is kind of a knockoff of, I think it's called the Dust Deputy or something like that. It sounds like a 25 or 30 gallon plastic barrel. And what is supposed to happen is that the majority of the dust and debris and dirt and things you suck in through the vacuum hose is supposed to go through the cyclonic collector, go straight down into the canister, and never really reach the filter on your shop vac. That's supposed to be kind of its own separate system, its own separate unit. That being said, after hours and hours and months of use, some dust does get by. It does get through, especially the very finest of particles. And I'm thinking that's probably what happened on this one. So I'm looking at my filter here, and it's full of just all kinds of dust. It still had pretty decent suction, nothing really sounded different, although it was probably just, one of those instances of just very minor and slow changes, over the hours and months and years that I used it. Maybe I just didn't notice. I thought the suction was still just fine. But what I'm thinking happened is that filter did end up getting a little bit overloaded, which put a little extra work on the motor and probably melted that thermal fuse again. Hopefully it didn't burn up the motor. Hopefully we don't need to replace that, at which point it may make as much sense just to toss this and get a whole new system. I don't know. But we're going to check it out. We're going to take it apart and see what we can figure out. But just let this be at least lesson one. Even if you're using a cyclonic dust separator or kind of an auxiliary system for collecting your dust, make sure you're still checking and cleaning your filter regularly. Probably wouldn't hurt just to get a whole new one. You can see that one's very well used. It's been blown out and cleaned out, probably 100 times over the years. But at any rate, the dust still does get through and probably, inhibited the airflow enough that it overheated the motor and finally killed that new fuse that I had changed, a few years ago now. So what we're going to do, I'm just going to take you through my basic troubleshooting process. I'll try not to cut the video too many times, if at all. And at the very least, I want to figure out or try to somewhat reasonably determine what the problem is. And then we can talk about repairs and moving on from there. So first thing I want to do, I got a meter, I've got a drill gun, I've got this bit set for taking it apart. Sometimes appliances, tools, parts like these have security bits to keep you from tampering with them. That's where something like this really comes in handy. Let's see, there's probably about 20 some bits here. 2, 4, 6, 8, 10, 12. So about 32 bits, I think, actually came with this. Anything from security bits to specialty bits to just your regular Phillips flatheads. This pretty much covers it all. What's nice with these, they're about 6-inch bits. So they get down into deeper spots where a lot of times if you're using like a insert style bit driver, a lot of times you can't get into a lot of these, you know, areas and screws. This really helps to take care of that. I'll see if maybe I can leave a link to where I got this in the description, as well as maybe a couple other tools I might be using. But first thing we're going to do, as you should always start, is verify we do have power and that this unit is in fact dead and that it wasn't maybe a bad outlet or something else going on. So I'm going to check my extension cord here. Hot is the smaller of the two holes, and I do have 124 volts AC. Another thing to keep in mind, this is a relatively high amp draw device. So if you're using a really long and a smaller gauge extension cord, that can draw quite a few amps as well. Sometimes you'll flip something like this on, immediately trip a breaker, or it may not even get enough current to even power the device on in the, you know, to begin with. So keep in mind, this is a very short extension cord. I know the power is good, so we just wanted to check that first. And we're going to plug this in. And turn the switch on. It's actually already on. And so the unit is not working. Now there's a couple possibilities here. There could be a break in the cord. The switch could have gone bad. Again, what's likely to have happened is that the thermal fuse got hot, overheated, and melted, and is now open so that we're not getting current through the cord into the motor. So that's what we're going to verify next. This all appears to be standard number 2 Phillips. So we're just going to start taking these apart. Normally I try to magnetize these bits. I haven't done that to these yet, as it makes things a little easier to pull out. And that should be all of those. We're going to take this muffler off just to get it out of the way. Take as many of these screws out so we don't lose them. That's where a magnetic parts tray would come in handy. I got about 100 of those around here. Forgot to grab it. And these all look to be the same size screws, give or take, so they should be able to go back in just about any order. Set those safely out of the way. Cover comes off. Here's the main motor. Here's the switch. That's actually going to be the first thing I'm going to check now that it's open. I've got everything unplugged again. Set our meter to continuity. Should give us an audible tone. With continuity, and try to see which. So on is towards me. If the switch is good, we should have a beep here. And we do. Actually, go ahead and unplug one of these so I can get a little better. And turn it off. And that's off. That's on. That's off. So the switch is good. Another thing we can check pretty easily is that our motor leads are still good from the switch. That one is. And then this blue covered lead, the red goes to the motor, blue goes back to the hot lead of the power cord. So we'll check continuity there as well. That's going to be your smaller of the terminals. Common or neutral will be the wider one. We'll check the hot side, and we still have continuity there. Then we have the common going into this side of the motor. We'll put our meter on there and switch to the other terminal. And we have continuity there. So we do have continuity from the prongs of the cord all the way to the motor, as well as to the switch, which is all good. So what that tells me is that either the motor has finally fried or the thermal fuse that I replaced has melted or something else has become disconnected. So one thing we'll do, we'll reach in here to the fan blade, the blower blade, make sure nothing's seized up, and it seems pretty loose. I got a little bit of dust, a little bit of shavings here. Has to be expected after so many years. But we want to now get this motor unmounted. Looks like we've got a couple more screws here. This assembly splits apart. So we'll take these out. And all these screws still look like they're the same size, so we're not going to worry about keeping anything separate. It looks like I missed one. A little bit of dust in everything. We'll clear that out. You know, that's never going to help. But our little impeller, this is where the blower and suction air comes from. This impeller seems to be fine. Everything's still spinning good. So the motor hasn't locked up. It hasn't melted down. Give it a smell test. I don't smell anything, you know, too obviously burned up. Now I'm thinking we probably there's like a secondary for the air channel to blow through. We'll take that out of our way for now, clean that up later. Now we probably need to take this impeller off to get the motor out of this unit. I'm gonna have to get a socket set. Let me grab some wrenches. Maybe metric. See if a 13mm will work. Comes off easy. This goes here, and then we got 2 screws holding it together. Now these are a little bit different than the others, so we'll set those aside. And just like that, we got the motor out. And another thing, this is a brushed motor, so we'll just kind of visually check the brushes. And it looks like there's still good contact there on that one. Still contact there. And just connect our wires so we can get this bell end off. And looks like last time I worked on this, I marked a little N here for neutral. And a B for black or hot. So we'll be able to keep those straight. Disconnect those. And again, there's our brushes. They look like they're in pretty good shape still. There is a spring inside this that's pulling those in towards the center. We'll get an air compressor, blow a little bit of the carbon dust out, but the brush is still looking good shape as far as I could tell. I'm trying to remember, I thought there was a thermal fuse in here. Unless I'm misremembering where that went. Take the other bell end off at the fan blower side, and this can come out. Looks like we've got a little bit of wear here. Almost looks like that was machined in though. Not sure. Otherwise it'd be all the way around. So I think we're okay. And I guess this is the rotor. Maybe put a little contact cleaner right here where the brushes contact, but those should be fine. And let's go ahead and check our coils. Looks like there's 2 coils. We'll go one side to the other. Okay, I've got continuity on one side, nothing on this side. So either I've got a break in this coil or that's where my thermal fuse was, and now I'm starting to see it. Take this little woven insulation back. Looks like there's some heat traveling back from this side, so this definitely got hot. Kind of has 2 insulative protections on it. So here's your thermal fuse. And I'm gonna guess that I have no continuity between the ends here. So we'll check. It is open, so I'm just checking that I have conductivity on the legs, which I do, and there is an open there. So I'm left with a couple options. One, I can find a replacement thermal fuse here, you know, crimp a new one into there or solder a new one on there. You do have to be careful, obviously, when soldering these that you don't melt them. This one, I believe I actually crimped back in place. I know it's kind of hard to see in here. I think I made some little crimp connectors. Just crimped it on there. Another thing I'm actually tempted to do is get a resettable switch with a length of wire, you know, to go somewhere on my motor housing. I'll drill and mount it out of the way. And I can get one that I can reset, or I could just, you know, get a new fuse and call it a day. We'll see. I haven't quite decided yet. The other option, obviously, is just to eliminate that switch. If you really needed to get this going, you could eliminate that fuse rather, or put a different style in there. you know, just crimp or solder your coil wires back together. May still even end up doing that and then putting the switch in between these spade terminals somewhere. So, you know, there's a few different options there, but we have successfully diagnosed the problem. I just wanted to take you guys through that little procedure there, taking everything apart, taking the motor apart, checking the basics like the brushes, continuity on the switch and the wires and the coils. It's a pretty simple system, simple motor. You know, you could buy these replacement motors too, I would think, for hopefully relatively cheap, or harvest one off another, you know, shop vac that maybe something else is bad on. But we're going to try to use and keep everything together as much as we can. So figured I'd show that to you guys. I do have some resettable fuses coming later today. They actually should be here shortly. Maybe I'll go through that process with you guys. I'll show you how I'm going to do that, kind of hack this a little bit so that, you know, if and when this does overheat or draw a little bit too much current in the future, we could just easily reset it and not have to tear all this apart like we just had to. Now, there's a caveat to that, obviously, and I'll probably talk about this in the next video, but you are altering, you know, a product as it was designed. So obviously you're voiding any warranty if there was any. This thing's 15 plus years old, so there isn't a warranty anymore. And, you know, you're modifying the original design, so that has its own inherent risks that you need to be aware of. You know, even replacing this fuse, these aren't really designed to be replaced. This isn't designed, you know, they don't want customers digging into this necessarily and opening up, you know, what could be potentially dangerous equipment. So, you know, keep all that in mind. We like to fix our own stuff here, so that's why we're doing it. So hopefully you guys learned a little something, and if I do replace or modify this, I'll make a separate video for you guys to watch, and we'll try to link that as well. Thanks for watching, guys.